This is Java OCA Unit 4 Lecture 2, Constructing Strings with the StringBuilder class. In this lesson, we will be discussing mutable string objects, and we will look at the methods of the StringBuilder class. StringBuilder objects are mutable strings. Since the StringBuilder class belongs to the java.language package, it is automatically imported for every Java class. StringBuilder objects outperform string objects in Java because a string is immutable, therefore creating new objects every time a string is modified. This consumes memory and it slows execution. However, StringBuilder objects are mutable. This makes for a more efficient and frequent concatenation or string modification, or for large string construction. So here we're going to look at some of the ways you can use the StringBuilder constructors. You'll notice on line 5, we have a declaration of a StringBuilder object, and then the new word instantiating a StringBuilder. The default will set the StringBuilder to a size 16 character capacity. And when we print this out, you'll see that the first line of code is empty. Then we have a second StringBuilder object, SB2, and it's being initialized with a constructor that receives a string. So this will have a character capacity of the length of this string, which is 4, plus 16. So it will be a total capacity of 20 characters, but it will have 4 characters stored in it. And we see that when we print it here on line 8, we get a printout of just Java. And then on line 9, we create another StringBuilder object, SB3, but we instantiate it with a previously declared StringBuilder object, SB2. And you see that when we print it, we get Java again. And StringBuilder 4 receives an integer of 25. So instead of having an initial character capacity of 16, we now have set it to an initial character capacity of 25. And when we print this out, again, we get an empty printout. There's nothing there to print. It's not storing any characters yet. So here is a list of the StringBuilder class methods that we will look at in this presentation. You'll notice that some of them are similar to the string class, most of them are different, and even the ones with similar names will have different behaviors. So first, let's address the method length versus the method capacity. The length method returns the number of characters that are stored by the StringBuilder object, where the capacity method returns the current size of the character array, which stores the characters of the StringBuilder object. So you can see down below in the picture, we have a capacity of 16, which is numbered from 0 through 15 on the index. And the length is 13 because it consumes from index 0 all the way up to index 12, including the spaces at index 4 and 8. And it starts counting from 0, so the length of the characters is 13 that is stored by this example. So now if we consider example 1, where we have a StringBuilder object SB1, it is initialized with empty parentheses. So we said on a previous slide, that means the capacity by default will be set to 16. And then we're going to append the word hello to it. So it does not increase the capacity at all. So the length of this StringBuilder object would be 1, 2, 3, 4, 5, and the capacity is 16. Here, for example 2, SB2 is instantiated to have a capacity of size 32, and the length is the length of this string that we have here. The length is 23, that is including the spaces and the punctuation that were used, the comma and period, and the capacity is still 32. So now if we look at some other examples, here we have StringBuilder object SB1 being instantiated with a string code, and since that has a length of 4, they're going to add 16 to it because the string is being passed during instantiation. And during instantiation, you're going to get a default of 16 additional characters. So this has a capacity of 20. But when it asks what is printed by line 2 is going to print code. What is the length of SB1? The length is going to be 4. And if they asked what was the capacity of SB1, the capacity would have been 20. After that, we have a second StringBuilder object. It is being instantiated with an integer, so it sets the capacity to size 32. And when it asks to print out SB2, we did not add any characters to it. We did not initialize it with a string, so it will have a blank output. It is an empty string. So what is printed by line 4? Nothing. This is an empty string. And then what is the character array capacity for StringBuilder 2? StringBuilder 2 has a capacity of 32. And what is the character array capacity for StringBuilder 3? If we look at StringBuilder 3, it has an empty set of parentheses, so the capacity would be 16. And if we did sb1.capacity, this would return 20 because we said the 4 characters of the string plus the 16 that happened during instantiation. So the first of our methods that we're going to look at is the append method. This simply adds characters to the end of the StringBuilder string. So if you have an empty string, it would set up the first characters. If you had an existing string, it would tack it onto the end. So here we have a StringBuilder SB1 with a default constructor, and it's going to have a capacity of 16, but has no characters in it. When we append A to it, StringBuilder 1 now stores A. When we look at line 2 here, StringBuilder 1, SB1, has an append lot, so it now stores a lot. And now we see here there is no quotes, it is just a Boolean value, but it will append that Boolean value. The append method can receive as a parameter many different data types, and Boolean being one of them. So now SB1 would store a lot true, no spaces. And here on the 4th line, we have a double parameter. So now SB1 would be a lot true 3.14. And those are all of the characters that would be stored in the character array for the StringBuilder object. So the append method can also accept character array types, object types, other StringBuilder types, and character sequence types. So we have an example here. StringBuilder SB2 is initialized with a string hi. So that is length 2 plus the 16 that we get at instantiation gives us a capacity of 18. And we have a character array, ARR, which holds the character 5, character 0, character %sign. Notice they're all in single quotes because they're characters. What is the value of SB2, this should say, after each append statement? So it starts with hi, and it's going to take SB2, append SB2, so we have hi. And then we're going to append ARR, which is this array, so we have hi, 50%. And then we're going to append a new dog Rex, assuming that Rex is a parameter for a dog class constructor, and it is going to append what is stored by the new dog variable, hi, 50%, and it's not going to append Rex, it's going to append dog class at some pointer value. And this is what would be stored in the character array for the StringBuilder object SB2. So on that previous slide, we said that we have character sequences as a type that the StringBuilder constructor can receive as a parameter. And a character sequence is an interface of the Java language package, and it allows access to a sequence of characters. And recall that interfaces, just like abstract classes, cannot be instantiated. So the character sequence can serve as a data type, but it must be instantiated by the StringBuilder class or by the string class constructors. So here we see on this first line, we have a character sequence declaration. The variable name is CS1, and we are instantiating it with a string constructor abxyz. And then we have a StringBuilder object, variable name sb3, new string builder. So this tells us that we have a default character capacity of 16. And we're going to take sb3.append cs1, which is our character sequence, and it's going to take sequence of characters from 2 to 4. So 0, 1, 2, 3, 4. It will give us abxy. And you should recall from the string class, anytime you do substrings, it goes up to but not including the second index with strings, and that is the standard way that Java does a range of indices with arrays and strings throughout all of its methods. And here we could just append SB3 with CS1, so it would add the entire CS1 character sequence to it. So we would have ABXY from the previous line, and then ABXYZ. The insert method allows us to place a specified data type at a particular position within a StringBuilder object. We say a specified data type because it could be a character sequence, it could be a string, it could be a character, it could be a double, and so on. So we have here the StringBuilder word, new StringBuilder start. 1, 2, 3, 4, 5 is the length of the string. So the initial capacity is 5 plus 16. This has a capacity of 21 and a length of 5. And we have a character array, ARR, holding letters LEAP. And it says what is the value of the StringBuilder object word after each insert statement. And we see that for word, we're going to insert at index 0 a capital X. So we now have X start. And then we're going to insert at index 5. So 0, 1, 2, 3, 4, 5. So right in front of the T, we're going to insert from the array characters 0 through 2, but not including 2. So 0, 1, 2. So LE. So we now have X, STAR. In front of index 5, we're going to put LE, and then there's the T. So we have X starlet. And then we're going to do word.insert word length. Well, the word length now is 1, 2, 3, 4, 5, 6, 7, 8. The word length is 8, but the index is 0, 1, 2, 3, 4, 5, 6, 7. So at position 8, we are allowed to insert. We're allowed to insert 1 past the index, but no more. It would cause an index out of bounds error. And it will insert coder at the end. So this is no different than the append method. Insert at word length is the same as append. And we have X starlet coder. And that's what would be stored by word. So now we want to discuss equality statements with StringBuilder objects. The StringBuilder class does not override the .equals method from the object class, and therefore, if we were to compare two StringBuilder objects with a double equal sign or with the .equals method, they would be equivalent. They do the same thing. They compare pointers or references and nothing more. They do not compare the content of the strings. However, if we did want to compare the content of the StringBuilder objects, we can convert them to strings first. And I've demonstrated this in the code on the right side here. you'll see that we have word 1 is a string builder object storing hello world. Word 2 is a string builder object with initial capacity of 32, also storing hello world. And if we compare word 1 to word 2 with double equal signs, it's going to print out false. And if we compare word 1 to word 2 with the dot equals method, again, it prints out false. It doesn't work the same way as the string class because the string builder did not override the dot equals method, so it only compares pointers or references between the objects. Now I'm going to convert the string builder objects to strings so that we can compare their content. And you see here on line 15, I have a string str1 and it is equal to word.toString. So we use the toString method, which is defined in the string builder class. And we use that to store word 1 and word 2 into string 1 and string 2 respectively. And when we compare them, we see that a double equal sign still produces a false, but the dot equals method, which is now defined for the string class, returns a true. So even though word 2 had a greater capacity of 32 versus 16, that has no bearing on the dot equals when we convert it to a string. It just takes the characters it's actually storing, and it showed that yes, they were both storing the same hello world characters, and it came out true. So often if we wanted to use methods or techniques that we are familiar with from the string class, we want to first convert our string builders to strings, and then we can use those string methods. Here we have the delete method and the delete character at method. The delete method will remove a series of characters from a string builder object using a specified substring of index values. So you need a starting value and an ending value. And the delete character at will remove a single character from a specified index. So here we see string builder 1 has a new string, cats and dogs, and it deletes from 0 through 7. 0, 1, 2, 3, 4, 5, 6, 7. And again, we go up to, but not including the ending index. So D for dog will stay in there. And we have dogs is what will be left in string builder 1. And SB2, delete character at 1, will 0, 1. It's going to delete the W. So SB2 will now store sing. So here we have the trim to size method, which reduces the capacity of the character array to match the length of the characters stored by a string builder object. However, it will not trim the blank spaces like the trim method found in the string class. So if we look at the given string builder object word, which is instantiated with the string race car, if we look at word.capacity, it will be the length of the string, which is 1, 2, 3, 4, 5, 6, 7, plus the 16, which gives us 23. And if we trim to size, it will return 7 because that is what racecar is storing. If racecar had a blank at the end, it would trim it down to 8 because it would not trim the blank. But in this case, it does not, so it will become size 7. The reverse method simply reverses the sequence of characters stored by a string builder object. So if we look at the word pizzazz stored by the string builder object and we reverse it, it would give us zazip. Again, this has a length of 1, 2, 3, 4, 5, 6. So 6 plus 16 would be our initial capacity. This would still have a capacity of 22, and it would still have a length of 6, just in the reverse order. Next, we have the replace method, and it replaces a sequence of characters identified by their index positions with another string. And the length of the sequence of characters replacing does not have to match the length of the string. And you can see here, we're going to remove indexes from 0 through 4, not including 4. So 0, 1, 2, 3, that are 4 characters we're going to remove, and we're going to replace it with 3 characters. So when we update the phrase singing birds, we replace sing with fly, and when we print it out, it will print flying birds. So the length of the characters you are replacing does not have to match the length of the string you are replacing it with. And the last of the methods we're looking at are substring versus subsequence. There are two methods in the StringBuilder class that can be used to retrieve a subset of characters, and these are the substring and subsequence methods. They work very much the same way as substring does for the string class. Subsequence has a return type of character sequence, which we discussed earlier in this presentation, and the substring returns type string. So substring works exactly as we expect. These come from the Oracle StringBuilder class definition of methods, and we can see that substring is no different than what we saw in the string class, and subsequence only has one option where it receives two index parameters, your starting and ending index, and it'll return it as a type character sequence. So this is the end of this lecture. Go on and do the practice problems, watch the video and take notes again if you need, and continue with the rest of your assignments.